So the first thing I want to do when I'm trying to come up with an encoding ladder, and whether it's an encoding ladder for a single file or it's an encoding ladder for a category of files, is I want to find the ceiling. And the ceiling is the lowest full resolution data rate that delivers acceptable quality. So if you're working with a 1080p source file, you're going to have the highest quality source file that you actually ship, or the highest quality encoding file that you're going to ship. That's the ceiling. And when I find the ceiling, I first use a technology called CRF, then I get confirmation from VMAF, and we'll look at Hollywood proof as well. And then we'll, once we figure out the ceiling, it becomes a simple matter to choose the rungs and choose their data rates. So what is constant rate factor encoding? Constant rate factor encoding is an encoding mode in X.264, X.265, and VP9. And it adjusts the data rate to achieve target quality as opposed to adjusting quality to achieve a target data rate. And when we encode to CBR or VBR, we say, give me 500 megabits or kilobits per second, and the quality goes up and down to match that data rate. With CRF, it's just the opposite. It's give me this quality level and adjust data rate up and down to give me that quality level. And the quality range for CRF is 1 through 51, and the lower the score, the higher the quality. So if you're looking at a simple FFmpeg script, what you would see is that this is a data rate focused encoding string where I'm saying, here's the input file, here's the output file, give me 500 kilobits per second, and vary the quality if you need to achieve that target data rate. And then here's CRF again, input output. You say, give me CRF 23 quality and vary the data rate up and down to deliver that. And in this case, CRF is giving us a measure of encoding complexity, meaning it's telling us how hard that file is to encode. And from that, we can figure out what the ceiling is. So how do we do that? I wrote a book called Encoding by the Numbers. Basically, what I tried to do in the book was I used these 8 files to measure pretty much every key decision, decisions like what's the ceiling, what's the keyframe interval, bitrate control, B-frame interval, reference frame, all that stuff. So what I did is I used a bunch of different files because we all know all files encode differently. So we've got some movie files in here, we've got some animated files, we've got some synthetic files for business use, and then we've got a music video and some simple, talking head files. And what I did is I encoded the files using CRF 23, as we just saw in the previous slide. And what I found was that the data rate varied from 1 megabit per second to over 6 megabits per second. So for the PowerPoint and talking head tutorial, which would look very much like what you're looking at now, I could get a data rate of 1 megabits per second and a VMAF score of 96.68. Now 96.68, we spoke 10-15 minutes ago about the fact that any score above 93 is going to be pretty much perfect to the viewer. So with a tutorial, 1 megabit per second did it. With a movie-like production, 6 megabits gave me 92.74. So I'm almost there. Probably would be pretty high quality video file. But what we're seeing is that the data rate varied by over 600%. The VMAF ratings range from 92.74 to 96.88, which is a standard deviation of 1.39, which is pretty minimal considering that the VMAF score is from 0 to 100. And then as we talked about, what we're seeing is a talking head. I can use half the bit rate and get pretty much the same VMAF score as a haunted house type video, which for me validates the benefit of per title encoding. If you're not looking at per title, if you're using a fixed bit rate ladder for range of input sources, then you're either wasting bandwidth on one hand, not delivering sufficient quality on the other hand, or some measure of both. So from my perspective, if you're trying to find we're starting again with trying to find the ceiling. If we're trying to find the ceiling, encode the file or a category of files at CRF 23, which is going to correspond to anywhere between VMAF 93 to 96, which means that should be sufficient quality to ship without noticeable degradation in the file.